So now we're on the chapter 10 of season A1 course. Sa application layer, we're on the last layer of TCP/IP model and OSI model. So application layer. So in this chapter, we will explore the role of the application layer and how applications, services, and protocols within the application layer make robust communication across data networks possible. This activity. So application layer. So it is the uppermost layer in the OSI and TCP/IP model. So it is the closest to the end user. So as shown in the figure, so it provides the interface between the applications used to communicate and the underlying network over which messages are transmitted. Okay. So we have here some of the protocols of in the application layer. So we have the domain name system, HTTP, SMTP, POP, HTTP, FTP, and IMAP. So in the application layer on the OSI model, we have three upper layers: the application, the presentation below the application, and the session. So presentation and session. So on presentation layer, we have three primary functions. So formatting or presenting data at the source device into compatible form for receipt by the destination device, compressing data in a way that can be decompressed by destination device, and encrypting data for transmission and decrypting data upon receipt. Okay, so as you can see, we have different protocols or standards. So for file formats, we have the MPEG for QuickTime for video, and QuickTime and MPEG for video. Then graphics, JF, MPEG, and PNG for images. For the session layer, so as the name implies, functions of the session layer create and maintain dialogues between source and destination application. That is the work for the session layer. So it also handles the exchange of information to initiate dialogues, keep them active, and restart sessions that are disrupted. Okay. So we have here some of the protocols in the application layer. So we have the DNS, domain name system. So it's the name translation to IP addresses. The Bootstrap protocol, the HCP for assigning IP addresses. For email, the SMTP for sending email to server and server to other servers. The POP, post office protocol, so for retrieving email from a mail server. Then IMAP is protocol for, so it's the same with POP. So the only difference is the IMAP leaves a copy. It's stored in the mail server. For file transferring, we have the FTP and TFTP. TFTP, so it is connectionless file transfer protocol. So it's a UDP transport, while the FTP is it's a TCP. And for web, we have HTTP, so hypertext transfer protocol, and HTTPS. So it's secured HTTP. Activity, application, presentation, protocol standards. Okay. Application JF, we have for presentation, POP, IMAP, FTP, JPEG, MPEG, DNS. Okay. So for the TCP/IP model, so all of this is applicable for application in the TCP/IP model. So client server model. So the one that is requesting for services, we have the client and server for giving services. It's the client servers. So files are downloaded from the server to the client. Okay, let's see. download and upload. Peer-to-peer networks. So in the peer-to-peer networking model, data is accessed from peer device without use of dedicated server. So it's a peer-to-peer networking. So all of the nodes can act as the server and also the client. So in peer-to-peer exchange, both devices are considered equal in the communication process. So in a P2P network, so two or more computers are connected via network and can share resources such as printers and files without having a dedicated server. So it can function as a server and client. Peer-to-peer applications. Okay, we have. So it allows a device to act as both a client and server within the same communication. So in the figure, so both clients simultaneously initiate a message and also receive a message. Common P2P applications. Okay, we have the eDonkey, G2B torrent, and Bitcoin. Nutella, so Gnutella. So it allows P2P applications to search for shared resources on peers. Okay, so they are sharing resources. So in a network, so everyone has, I think everyone has the copy or files which can be accessed by the other computers. So okay, so some peer-to-peer applications are based on the Gnutella protocol or Nutella protocol, so where each user shares full files with other users. Okay, so they can search the files to other computers. HTTP markup language, hypertext markup language, HTML. Okay. So when a URL is typed in the web browser, so the web browser establishes a connection to the web service running on the server using HTTP protocol. So HTTP is, so it's for web traffics. Okay. So this in the example here we have. Okay, to better understand how the web browser and web server interact, we can examine how a web page is opened in a browser. Okay. So example is use the, okay, we access the cisco.com. Access that. So first, as shown in figure 1, the browser interprets the three parts of the URL. So you have the protocol here, the HTTP, domain name, so we'll just get our food. So for the continuation of chapter 10, so HTML and HTTP. So when a web browser is typed, web address or URL is typed into the web browser establishes connection to the web service running on the server using HTTP protocol. To better understand how the web browser and web server interact, we examine how a web page is opened in a browser. For example, okay, we are accessing this URL here, so cisco.com index.html. So in the router. Okay, so first one is, so it interprets the three parts of the URL, so the protocol, the server name, and then the specific file, so index.html. So in figure 2, okay, so they're converting it to okay, so it converts the domain name into a numeric IP address, so which uses to connect to the server. Okay, then accessing the file to get the request, then sends the HTTP server now sends the HTML code, and then so now the browser deciphers the HTML code and formats the page for the browser window. Okay, so that is the HTTP, and it's work to web. Okay, we have 3 common message types in HTTP. We have, first one is GET. So GET is most commonly used for requesting HTML pages. For POST is uploading data files, so for like the form data. And then PUT, so uploads resources or content to the web server. So for example, we have the image or videos. Okay. Next. So email protocols, we have, for example, so in this figure we have email clients. So one of the primary services offered by our internet service provider is email hosting. Okay, it's to run on our computer, so email requires several applications and services. So it is a store and forward method of sending, storing, and retrieving electronic messages across network. So email messages are stored in databases on mail servers. Okay, we have, so mail servers also communicate with other mail servers. So an email client does not communicate directly with another email client when sending email. Instead, both clients rely on the mail server to transport messages. So we have 3 protocols for email. So we have the SMTP, so Simple Mail Transfer Protocol for transferring email. The POP3 or IMAP, it's for accessing and retrieving mails. The SMTP operation. Okay, so the client sends an, let's see, if there's stock or forwards. Okay. So when a client sends an email, the client SMTP process connects with a server. So on a well-known port. So after connection is made, the client attempts to send the email to the server across the connection. So when the server receives the message, so it either places the message in the local account or it forwards to another server, mail server. So in SMTP or email protocols, so we are dealing with lots of servers, email servers. So POP operation, so we have, so server sending the email to another server for retrieving it by the recipient. We also have another protocol for retrieving emails. We have the IMAP. So the main difference between these two is, so after retrieving email from the server, so email would be deleted. But for the IMAP, or what is IMAP? So internet mail. So for the IMAP, we have copies of the message, so are downloaded to the server. There are copies. So emails are even after the recipient received or retrieved the email, so copies of the messages are stored in the server. So domain name service. So domain name service is, so it's a protocol for translating our domain names into IP addresses. So for much easier for people to remember. Okay. Then is message format. So we have, I think they use the same. Okay. So DNS uses the same message format for all types of client queries, server responses, error messages, and transfer of source record information between the servers. Okay. So the header, so this is the DNS message. Header, the question. So this is the request for the name server, the answer. Then it is the response, authority, and additional. Okay. So then a server stores different types of resource records used to resolve names. It may contain the name, address, and type of record. So some of these records are A, so it's an end device with IPv4 address, an NS, so it is a name server. 4As or quad A, it's an end device with IPv6 address, and mix, a mail exchange record. Then is hierarchy. So DNS protocol uses hierarchical system to create database to provide name resolution. Each servers or group of servers have different zones for managing name to IP mappings. I have the records for cisco.com. So this local DNS server. Also have the top level domain servers responsible for .com, .org. Okay, so for then the root DNS servers. So the hierarchy looks like an inverted tree with the root at the top and branches below. DNS uses domain names to form the hierarchy. Okay. The hierarchy of DNS servers contains the resource records that match names with addresses. So when a DNS server receives a request for name present, it's not good. Okay. So like with emails, so we're working also with a lot of servers. So if the domain name is not on the server, so it will forward to the message to the domain server to resolve the IP address. Then is lookup command. So it just displays the information about the DNS server or servers. It displays the IP address for the domain name. And let's look up. So okay, so computer OS also have a utility called NSLOOKUP that allows the user to manually query the name servers to resolve a given hostname. You can also use the NSLOOKUP at facebook.com. So it will display the server and then the IP address of Facebook. DHCP, so it is used for assigning IP addresses. So it can be, it's a dynamic host dynamic assigning of addresses. We also have the alternative to dynamic addressing, so it's just static addressing. So DHCP is most commonly used for large networks. We can also use our home router as a DHCP server. DHCP operation. Okay. So when the client boots up, it should be discovering the IP addresses. They'll find another DHCP server. It will discover the DHCP server. Then the server will offer the address, and then the client will respond with the request and an acknowledgement from the server. So if it's if the IP address is available, so it will be acknowledged. File transfer protocol. So it's a protocol for file transferring, so over the network. We have the FTP. Okay, so to allow data transfers. Okay, data transfers between client and server. So FTP requires two connections between the client and server. We have the first one is the client establishing the first connection to the server for control traffic. Then the second one is for data traffic, for actual data transfer. There are two connections. Server message block. Okay. So it's a file sharing protocol. So most commonly used with printers, for sharing printers. It's a client server request response protocol. So servers can make their resources available to clients on the network. So it's a file sharing protocol. FTP. That's so it's a path tracers for multi-user. Okay. So I think that's it for application layer.